Okay, next function. Volt sensing. Okay, this is the where we actually sense the voltage of the engine, and if the voltage drops, we turn the PWM off. And what this is telling us, if the voltage drops below a certain threshold, that tells us the engine isn't running because the alternator is not charging the battery. I suppose it could also be that you're just drawing too much load off your battery, but with just the HHO system, that shouldn't be happening. But if you're, running an inverter and running your power saw off your battery or something like that, your voltage could drop low, and the HHO system, in order to preserve your alternator, will kick out. But the real purpose of this was not to preserve your alternator. The real purpose of this was to sense when the engine isn't running and then shut down. Because if the engine's not running, if you're just sitting with your key on, listening to the radio, we don't want the HHO system running because it's just going to be filling up your engine compartment with hydrogen. Alright, so let's have a look at that. Volt sensing. First we say yes. And now we have the on voltage. What you want to do is you want to set the on voltage higher than the off voltage. In other words, when the voltage comes up to this on voltage, the PWM will kick on. But then if it drops below an off voltage, which should be lower than the on voltage, if it drops below the off voltage, it will kick off. But it won't kick on again until it gets back to the on voltage. And this is so that you can't just have it turning off and on when it's right at the threshold between the on and off voltage. Okay, so let's just say we want it to be around 12.5 volts on voltage, and let's say we want 11.5 for the off voltage. These are not unreasonable. You'd want to check this out on your own car. Find out what voltage the engine runs with the alternator on. Go well below that for your on voltage, and then see what happens when you turn your engine off, what voltage you have. It's usually going to be below 12 volts. Okay, so let's go ahead and see what happens here. Right now Right now we're running at 13.9 volts, but I can adjust that. And let's see what we can do here. So it stays on because our off voltage is 11.5. There we go. Notice it says 11.1 volts, 11.0 volts. We have an error message here across the bottom, so now we have amps, volts. So we're showing 11 volts, and the amps are 0 because the PWM is shut down. It's beeping, and it's giving you a message so that you can know why it's off. And of course the duty percent is 0%. Okay, now let's raise the voltage back up. Again, right in the center of the dial, you'll see the voltage. Okay, now we're at 11.8, 11.9. Notice that's above the off voltage, but it doesn't come back on because we haven't gotten to the on voltage yet. Now, if the alternator were running, it's going to be well above 12.5 volts. That doesn't come on immediately because it doesn't want to come back on for a transient high or higher voltage. But there it goes. So at 12.8 volts, it's come back on. Now you can set these more severe if you want. On mine, I have my on voltage at over 13 volts, and my off voltage is just below 12 volts. And that way you're always safe. If the engine stops running, even if you have a rack and your engine stops, but the electrical system is still on, this will sense that voltage and it will shut the HHO system off, so you're not producing HHO.